All right, Chapter 4, Part 2. Navy Electricity Electronic Training Series Module 10, Introduction Wave Propagation Transmission Line Antennas. Distribution Statement approved for public release and distribution unlimited. End-fire arrays. End-fire array looks similar to the broadside array, the ladder-like appearance for the character for the both figure 428 view A with the current elements of the end-fire array. However, they're usually with 180 degrees out there, which each other indirectly with the by arrow. The construction of the end-fire array is like that of the ladder lying on side. The elements for horizontal with the dipoles and with the fire arrays and enclosed together with 1/8 and 1/4 of the length spacing that they are for a broader side array. Top view of the array, up and down, side view of the array. Closer spacing between the elements permits the compactness of the construction for this reef and the end fire array is preferred for the other way. The high gain, the sharp directivity of the duration, desired confined space, however, the close coupling create with a certain advantage of the radiation resistance extremely low, with sometimes low with the 10 ohm, with making the antenna off the greater. The end fire of the array is contained with a single frequency which can change the climatic atmospheric condition. The danger of the detuning is this. Radiation pattern. The radiation pattern of the parallel for a pair of parallel half-wave elements fed at the 180 degrees out phase shown in figure 429 view A with the elements shown with the bit space with the one half-wave length of the part within practice. Smaller pieces spacings are U with the radiation from elements of the L and M traveling toward P and begin with the 180 degrees out phase, moving the same distance move over the proximate parallel path of the respective wave runs from the elements of the remaining 180 degrees out phase. In other words, maximum cancellation takes place with the direction of the V. Some of the same conditions truly opposite for the direction toward P1 from P1 to P1 axis with the line with the least radiation from the end of the fire array. Figure 429 for the parallel elements 180 degrees out of phase. Consider what happened with the QQ1 and the energy rating from the elements of the M toward the Q reach for the element of the L at approximately 1/2 cycle of the 180 degrees. After leaving the source L was 180 degrees out of the phase element M with the wavefronts for the now phase same phase with the move that was over the Q with reinforce each other the same reinforcement the curve along with the same of the axis toward Q1. They simultaneously move toward the Q and Q1 developed a bidirectional pattern, but not always true with the end with the operation. Another application for the end fire principle is one with the elements on his phase, 1/4 wavelength apart with the end phase with 90 degrees from each other to produce an unidirectional pattern. In figure 429 view A, the elements A and B with a particular with the plane represented with the pave, therefore the end of the antenna appear with the view B with the antenna with the rotate with the quarter with the circle with the space with the round, the QQ1 axis with the scene with the plane with the elements themselves, therefore PP1 axis with the not particularly with the space with the not seen in the line, with the RR axis with the not seen with the line with the particular to the PP1 axis, as well with the QQ1 axis with the end fire with the rays of the direction and with the plane with the also with the no the quite as sharp. The reach for the right or broadness of the lobe can be seen with the following page for that path of the energy and rating with the midpoint of the element B toward point S of the view B. With this energy path of the A element on the other of the traveling site more than perpendicular to distance between the dipoles. Energy therefore does not combine with the exact phase towards S, although the maximum radiation cannot take place for the direction energy toward the two sources combines closely enough with the phase to produce considerable reinforcement. A similar situation exhibit the wavefronts traveling on the T, however, the wider angle of the Q to T produce the greater phase of the difference as a result of the decreased strength in or combined wave. Directivity occur with the on either one or both of the end fire array with along with the axis of the array with the shown with the broken air with the figure 428 view A. Hence the term end fire is used. The major lobe of the lobes lobes occur along with the axis of the array. The pattern sharper than the plane that is the right angle of the plate containing the elements in figure 429 view A. If the elements are not exactly halfway with the operation, not significantly affected, however, they become the required balance of the base phase relationship with the critical feeding of the array with the main must be symmetrical. Full of dipoles such as shown in figure 420 view A. The frequently because the impedance of the other terminal is higher with this effective way of avoiding the excessive external load. Another expedition reduces the loss of the U for the tubular elements for the wider diameter. Alright, gain in directivity. The end fire array of the directivity increase with the addition of the more of the elements while space the approach for the optimum. The directivity of the pattern with the two elements of the bidirectional system and the illustrated figure 429 view A show the radiation along the array with the axis of the plane with the perpendicular with the dipole. View B show the radiation along with the array axis of the plane elements of the pattern that developed the 180 degrees phase of the difference between the elements and additional elements introduced in smaller minor lobes. 90 degree phase difference for the energy phase of the pair with the end of the fire space with approximately 1/4 length of the wave. The unidirectional radiation can be obtained with the pattern, particularly with the plane with the two elements shown with figure 430. View A, the pattern shown view B, taken in the same plane with the sixth element of the ray with the 90 degree phase between the adjacent elements. Since both of the patterns show relatively gain only, the increase is gain produced with the sixth element array is not evident. The end fire array is the only unidirectional way arrays will wholly made up of the driven elements. Alright, 4/3 each of the unidirectional end-fire arrays. Alright, parasitic arrays. In small light bulb we place with a certain larger of the room and the illumination would be very poor. However, the reflector would be placed behind the bulb with the space of the front of the reflector would be brighter than the space behind the reflector would be dimmer. The light arrays would be concentrated also over the lens where both the front of the bulb with the lights would be even more concentrated, very bright with the spot would be appear with the front of the lens of flashlight with a particular combination of the small bulb with the reflector and the lens, the energy of the antenna can be reflected with the concentrated in similar manner, although we do not usually gain with the flashlight with the continue the comparison of the aim of the antenna flashlight with the expand with the meaning of the antenna gain of the spot of the wall will front flashlight between becomes 10 times brighter than when it was only with the open bulb of the lens with the reflector then produce the 10-fold gain light for antenna simple halfway with the antenna with the corresponding with one bulb with the flashlight suppose the antenna system to concentrate the radio wave so that the particular point of the field strength with the 10 times more than would be the same the distance from the halfway with the 10 and the 10 system should have the gain of the 10 parasitic array that represent another medium with the achieve the higher intent of the gain of the parasitic array that consists of one or more of the plastic parasitic elements play for the parallel with each other and in most cases the same with the top line of the site of the level the parasitic element is inductive the radiative energy coming from the driven element connected to the transistor. There's no way the connection it is no way connected directly with the driven element. When the parasitic element is placed, and so that it radiates away from the driven element, the element is directed with the direct plastic parasitic element is placed with the radiator over the driven element. The parasitic element is a reflector. Alright, directivity pattern result of the action parasitic element depending on the two factors. The tuning determine the length of the parasitic element, the spacing between the parasitic element and the driving element to a lesser degree that depend on the diameter of the parasitic element, since of the diameter, and so it has the effect on the tuning. Operation. When the parasitic element is played for the fraction of the wavelength, the wave of the driving element, the approximate resonant length is re-radiated into the re-radiated the energy intercepts. Parasitic elements effectively with a tuned circle coupled with the driven element, much of the two lining with the transformer coupled together, the radiated energy for the driven element cover the voltage to develop the parasitic element, which from the cell of the magnifold of the magnitude of the field with extend over the driven element, which of the end of the voltage induced the magnitude of the phase of the induced voltage depending on the length of the parasitic element, the spacing between the elements, and actual practical length of the spacing range with the phase of the magnitude of the induced voltage really cover the unidirectional horizontal radiation pattern with the increase of the given. Parasitic ray with a figure 431 view A with the parasitic driven element, the space of 1/4 of the wavelength of the part of the radiator, the signal comes with the driven element, the structure of the parasitic element, after the quarter second of the voltage developed with the parasitic element, 180 degrees out of phase, with the driven element that become the driven distance trouble the 90 degrees, become the induced the current lag with the induced the flux with the 90 degrees with the 90 plus 90 is 180 degrees of magnetic field set up with the parasitic element is induced. And the voltage is driven with the element for 1/4 of the cycle later, then because of the space between the element, the 1/4 wavelength of the induced voltage favor the driven element, the cover the chief is the increase of the radiation with the direction, increase the figure 431, where you A with the system, the direction of the radiation, energy shrunk with the direction away with the parasitic element, toward the driven element, the parasitic element is called the reflector. The radiation pattern is also, as it would appear if we're looking down on the antenna shown view B, the patterns would look at the view, the end of the elements is shown view C. View A with your parasitic element reflector, the radiated signal, the driven element, and also the radiation signal driven element reflector. Radiation signal driven element reflector. View C pattern showing the reflector with the proper spacing. Because of the voltage of the reflector 180 degrees for the signal produced with the driven element, the reduction signal strength of the existence between the reflector of the signal magnitude that induced the voltage near the quite equal the inducing voltage with the very closely coupled with the circle of the energy film behind the reflected minor lobe that are not reduced to zero. Space between the reflector driving the element can be reduced to about 15% of the wavelength. The parasitic element must be made electrically inductively before it will be as a reflector. Thus, the element is made 5% longer with a half wavelength. This will act with the reflector when the spacing is 15 degrees, 15% of the wave length. Changing the space of the length with it can be change the radiation with the maximum radiation of the same side of the driven element with the parasitic element. With the instant of the parasitic element is called the director. Combination of reflector and the director-driven element that cover the degree of the back radiation and the increase of the directivity of the combination result of the two main advantages of the parasitic array and directivity increase the gain of the parasitic array, the rotate of the pickup of the transmitted different direction, pick up of the reduction, transmitted energy in all the desired direction of the antenna of the type of the is called the rotary array. Since the size for side of the both the gain the directivity of the parasitic array greater than those of the driven array, the disadvantage of the parasitic array is that the adjustment is critical that they do not operate over the wide frequency range. Alright, gaining directivity. The change of the spacing between the Either director or reflector of the driven elements result of the change of the radiation pattern with the more gain of the directivity obtained with the change of the length of the parasitic arrays. Front to back ratio: an array with the proper is the proportion of the energy rated with the principal direction of the radiation energy rated in the opposite direction. The high front to back ratio is desired because of the means with the minimum amount of the energy is rated in the undesired direction. Since the complete suppression of such radiation is impossible, infinite radio cannot be achieved. Actual practice, however, rather than high values can be obtained. Usually, length of the spacing of the parasitic elements are adjusted for the maximum front to back ratio obtained rather than the maximum gain in the desired direction. Alright, multiple element parasitic arrays. Multiple element parasitic arrays arrays is one that consists of two or more parasitic elements, which for the driven element area contained with the two parasitic reflected director of the condition for the driven element, usually known as the three-way element array. The three parasitic elements are usually arrayed, known as a four-element array, is also generally speaking, if more of the parasitic are added to the three-element array, each of the added element is a director. Each added element is a director. The field behind reflectors is a small additional reflector which have a little effect of the overall radiation pattern. The radar if from 1 to 5 detectors are used. Alright, construction. The parasitic element with the multiple element parasitic array, usually the position shown in figure 432, view A and B with the proper space for the length to determine the experimental with the full dipole. View B is often used with the driven element to obtain the greater value of the radiation resistance. Alright, show the direction of the signal with the director of the radiator, the reflector, the director with the streamline, insulator, bollard, antenna, reflector, four-way, yagging pole, volt dipole, two-way wire shield cable. Alright, Yagi antennas. Example of multiple element parasitic array with the Yagi antenna of figure 432 for the view A and B. The spacing between the elements are not uniform. The radiation from the direction out of the mid array with the forward direction out of the phase of the area stays in out of the other direction. The director of the reflector of the Yagi antenna is usually welded to a conducting rod. The tube at the tube at the center of the support that does not interfere with the operation of the antenna. Of the driven element, the center fiber is not welded to the support of the center and impediment that can be increased by UV the folded dipole with the driven element. The Yagi antenna is shown with the figure 432 for the UA with the three director of the general, the greater number of the parasitic element, the greater is gain, the however the greater number of the such elements cover the array with the narrow frequency response, as well as the narrow bread beam width, therefore with the jump of the 10 with the critical gain, but it does not increase directly with the number of the elements U. For example, the three element Yagi array has relatively power gain with the 5 decibel, with adding another direction result with the 2 decibel increase with additional directors have loss of the less and less effect. A typical Yagi array is receiving and transmitting energy is shown with a supporting frame of the figure 433. The 10 energy with the multiple separately operating with a frequency 12 to 15 megahertz consist of two separate areas of one high frequency, one low frequency antenna arrays from the frame of the various elements of the indicator of the figure. The high frequency array with the consist of one reflective the driven element, the two directed low frequency array that has the same arrangement, one less directed. The length of the elements of the high frequency array are shorter than those of the low frequency array. The physical length of the elements of individual arrays are equal. The equal length of the may be varied means for the tuning stub of the same of the elements of the array with the rotate with any desired direction, the remotely controlled the electrically driven antenna and rotary. Or a typical parasitic array with a transmitter receiving director, high frequency director 2, high frequency director 1, high frequency director driven element, high frequency driven element, low frequency reflector, high frequency low reflector, low frequency. Or special antennas. In this section, we will cover the special communications radio antennas. Some of these antennas we'll cover briefly, and since they are covered thoroughly in other courses. Briefly discussing the antennas operating with the same wave of the current voltage along with the wire with the section of the deals precisely with the antennas if the current is practically uniform in all parts. The antenna basic form of the antenna consists of a single wire ground with its far end through the resistance of the resistor value of the equal to the characteristic impedance for the antenna. The termination just as the cover of the ordinary transmission line limited the sustaining wave current through therefore to decrease the uniform along the wire with the transmitter with the end of the approach with the decrease is covered by the loss of the energy through the radiation. The energy remains at the end of the antenna is dissipated. Terminating resistors such that the antenna is good radio. The length of the must be fairly long. Also, the wire must be too close, not to be too close to the ground. Returning the path of the ground will cover the cancel over the radiation of the wire with a sufficiently long. It will practically non-resonant over a wide range of the operating frequency. Low wire antenna. A long wire antenna. A long wire antenna is an antenna with a wavelength along with the operating frequency in general with the gain achieved with a long wire antenna that is not greater than the gain obtained with a multiple element array of the study in the previous section, but long wire antenna. There's an advantage of its own with the construction of long wire antenna is simple both electrical and mechanically with no particular with the critical dimension or drift. The long wire antenna will work with a given and satisfactory gain of the directivity over the frequency range up to the 2/12 the value of which it was covered. In addition, will accept the power of the radiative deficiency of the frequency with it over the length of it is not less than approximately one half the wavelength of another frequency factor of the long wire antennas are direct pattern for that are sharper than both the horizontal and vertical plane, but they also tend to concentrate the radiation low the vertical angles. Another type of long wire antenna is the beverage antenna. It's also called the wave antenna. The horizontal long wire antenna was described especially with the reception transmission low frequency, vertically polarized ground wave that is considered the signal wire 2 or more wavelengths long supported by the 3 to 6 meters above the ground, terminated with the characteristic impedance shown in Figure 434. So for the transmitter terminating resistor ground, both grounded. The V antenna. The V antenna is a bidirectional antenna we use the wire with the military and commercial with the communication consisting of the two-conductor range in the form of a V. Each conductor is fed through the current's opposite polarity. The V form of the such an angle with the main lobes reference along with the line bisectional with the V make the very effective directional antenna. Figure 435 connecting the two wire fed line with the apex of the V consisting of the two sides of the V with 180 degrees alpha. The cover of the lobe to add along with the line with the bisectional cam for the other directions is shown. Figure 436. Lobes are designated 1, 2, 3, 4 and leg AA and V 5, 6, 7, 8 and leg BB. The proper angle between A and BB. AA and BB is chosen. Lobes 1 and 4 have the same direction, combining with lobes 7 and 6 respectively. Combination for the two major lobes of each of the leg result of the formation of the two stronger lobes while lie along the imaginary lines bisecting the enclosed angle of the lobes 2, 3, 5, and 8 to cancel each other out due to the smaller lobe with approximately right angle of the wire legs of the V. The result of the waveform pattern shown to the right of the V antenna shown for Figure 436. The transmission wave direction 435 basic view antenna. The 436 the formation directional radiation pattern from the resident V antenna. Imaginary 1, 2, 3, 4, and 5, 6, and 7, and 8. Resonant redirectivity online. Rhomic antenna. The highest development of long wire antenna, the rhomic antenna is Figure 437. If the four conduct with the joint with the form of the rhombus, the diamond shape of the antenna is blade at the end with the terminated, the non-inductive resistor, but if the unidirectional pattern, rhombic antenna can be made with the two obtuse angle V antennas that are placed side by side, erected in the horizontal plane with the terminated with the antenna non-resident unidirectional. Top view. Transmission line length with the wire, the support the pole insulated until angle T, maximum radiation, maximum reception, terminal resistance. Transmission line, maximum radiation, maximum reception. In a rhombic antenna, widely used with a long distance with a high frequency transmission reception is one of the most popular fixed antennas because of the very useful in point-to-point communications. Advantage for the rhombic antenna is over the wide frequency range, although some of the change of the gain with the directivity change character for the impedance to occur with the change of the operation frequency. These changes are small enough to be neglected. The rhombic antenna is much easier to construct and maintain than other antennas comparable to the gain with the directivity. Other supporting pole with a common height of 15 to 20 meters underneath the antenna. The rhombic antenna also have the advantage of non-critical with the operation adjustment of the concern with the cup with the broad frequency change characteristic of the antenna. Still, another advantage for the voltage present with the antenna is much lower than those producing the same input power than the resonant antenna. The particular important with the very high when high transmitters are used when high altitude operation is required. Disadvantage of the rhombic antenna is not without its disadvantages. The principal one is a very large antenna required for its erection. Each leg has at least 1 or 2 wavelengths along with the lowest operation frequency. The increase of the gain of directivity is required. The length of the 8 to 12 wavelengths is used. These requirements mean high frequency rhombic antennas have the wire in several 100 feet over the length of the therefore they are even a large plot with the land that is available. Another disadvantage of horizontal vertical pattern depending on the shape of the rhombus commands is made with a narrow horizontal beam. The beam is lower for the vertical direction, therefore they obtain the high vertical angle of the radiation is impossible to exhibit with a very broad horizontal pattern. Low gain of the rhombic antenna is used. However, the long distance skywave coverage with a high frequency UV with these counter these conditions, low vertical angle with the radiation less than 20 degrees of the desirable rhombic antenna, the considerable amount of the input power is dissipated on useless. And the terminator resistor, however, the resistor is necessary to make the antenna unidirectional. The greater the gain of the antenna, more light makes up the further loss. Radiation patterns. Figure 438 shows the individual pattern produced with the foreleg of the rhombic antenna. The result in the radiation pattern of the principal radiation operator is the same for the V and the half rhombic antennas. Individual radiation patterns result in radiation patterns. All right, terminating resistor. The terminating resistor plays an important part of the operation of the rhombic antenna. It depends on unidirectional antenna. The lack of resonance effect of the antenna should be properly terminated, so it will have the constant impedance as an input. The terminating antenna will will also allow it to be operated with a wide high frequency range without necessity of changing coupling, adjusting over the transmitter description of against the signal coming through the rear of the greater importance for reception reduction over the back of the radiation is perhaps the less important for the transmission. When the antenna is terminated with the resistance, energy would be radiated back towards an absorbed resistor. All right, the turnstile antenna. The turnstile antenna is one of the main types of the developed primarily of the omnidirectional, very high frequency communication. Basic turnstile consists of the two horizontal half-wave antennas mounted with the right angle each over the same horizontal plane, with the two antennas are excited with equal with 90 degrees over the phase. The typical 4/8 patterns with the two antennas mirrored with the produce the nearly circular pattern shown in Figure 439 view A of the pair of the such antennas frequently stacked with the shown Figure 440. Each pair is called a bay. The Figure 442 bays are U with the end and are spaced with one half wavelength of the bar. Corresponding elements are excited in the phase ignition cover the part of the variation radiation each of the phases to cancel the other bay out. Result of the decrease of the energy radiated with the high vertical angle, the increase of the energy radiated in the horizontal plane, stacking the number of the bays that can alter vertical radiation pattern cover the substantial gain of the horizontal direction along with the overall horizontal pattern direction. Vertical Figure 439 view B with the comparison of the circular vertical radiation pattern with the signal bay turnstile with its sharp pattern 4-bay turnstile array, the three-dimensional radiation pattern of the 4-base turnstile antenna shown Figure 439 view A. For view A show the pattern AA point and BB resulting in the horizontal pattern of the A diplodes AA and BB vertical pattern signal with a vertical pattern 4 bays C. Simple folded dipoles phasing section lines of the transmitter lower bay. Your ground plane antenna. Vertical quarter wave of the antenna, several wavelengths ground produced with a high angle of the radiation, variable, unstable, very unstable, very high frequency, ultra high frequency frequencies. Most common means of the producing low angle of the radiation from the antenna is work radiated against the simulated ground. Again, ground plane simulated ground may be for a large metal sheet, several wires or rod radiating with the base of the radiator. The antenna control is known as the ground plane antenna. Two ground plane antennas shown in Figure 441 view A and B. Figure 441 shows the ground plane antenna, quarter wave vertical radiator, insulator ground wave plane rods for coaxial transmission line, antenna coner composed connector for mounting radials. Or your corner reflector unidirectional radiation patterns desired. They can be obtained with the corner reflector, half-wave dipole. The corner reflector antenna is a half-wave radiator with a reflector. The reflector consists of the two flat metal surfaces meeting an angle immediately behind the radiator. In the other words, the radiator is sent to the plane with the line bisecting the corner angle to form the reflector. Shoot the construct for the corner reflector shown in Figure 442 for the corner reflector antenna are mounted with the radiator reflected with the horizontal position. Horizontal plane polarization desired the edge of the cave of the radiation pattern of it is fairly narrow over the vertical plane. Maximum signal must be radiated in line with the bisector with the corner angle directed with the horizontal plane is approximately the same with any half wave of the radiator having the single rod type of the reflector behind it. If the antenna mounted with the radiator can only reflect with the vertical position shown in view A of the maximum radiation produced the very narrow horizontal beam radiation vertical plane will be and same as a similar radiator with a single rod type of the reflector behind it. Maximum radiation dipole antenna, repeaters, sheet reflectors, and corner reflector antennas. All right, radio frequency safety precautions. Although electromagnetic radiation with the transmission line with the damage usually insufficient strength with the electrocute person, it can be led by the other accidents of the computer compound injury. Voltage may be the injury with the underground metal objects such as wires, cables, wire guides, wire cable, house wires, handles, and ladders, and it can become in contact with these objects. Receive the shock of the radio frequency burn. The shock can cause you to jump or into the nearly mechanical equipment when working along with the fall with the elevated working area. Take care to ensure that all the transmission line and attempt to de-energize from working near on them. Either check or have some of the one else check all the guys check cables, rails, lighters around the work area of the radio frequency shock dangers. Using work aloft shifts and short safety harnesses to often satisfy or for your own safety. Assigning a working aloft shift to signify that all the equipment in the non-rating status that the person who signs the shift should be ensure that no radio frequency danger exists in areas where the other personnel will be working. Nearby ships or parked aircraft and are another source of the radio frequency energy that may be considered when you work with the area of the safety. Because possible material can be ignited several and can cause several fires from an arc heat generated from the radio frequency energy. Also, radio frequency radiation can be detonated ordnance device with inducing currents in the internal wiring with the device external testing equipment that's connected to them. Always obey the radio frequency warning sign to keep the sign of safety distance from radiation. Attention to the 6 type of the warning signals. Warning signs of the radio frequency radiation has shown in figure 443. Alright, radio frequency burns. Close to the direction of the radio frequency transmission line as the antennas may result with the radio frequency burns. They usually deep penetrate the 30-degree burns. To heal properly with the these burns, must heal from the inside to the skin surface. To prevent infection, you must give the proper attention to all radio frequency burns. Include small pinhole burns. The predolonium gauze can be used to cover the burns temporarily before a person reports medical facilities for further treatment. Alright, dielectrical heating. Dielectrical heating is the insulation of the material placed in a high-frequency electrical field. The heat results of the internal loss during the rapid reversal of the polarization molecule of the dielectrical material. In this case, the human in a radio frequency field of the body with the axis of the dielectric, the power of the radio frequency field exceeds 10 milliwatts per centimeter, and person in the field will have noticeable rise in body temperature. The size of the highly susceptible to dielectrical heating. For this reason, you should not be directly into the device radiating radio frequency energy. Vital organs of the body also are susceptible to dielectrical heating. For your own safety, you must not stand directly in the path of radio frequency radiation devices. Alright, precautions when working aloft. The radio or antenna are energized by the transmitter. You must not go aloft unless advised. The test shows that little or no danger exists. A casualty can occur for even a small spark drawn from the charged piece of metal rigging. Though the spark itself may be harmless, surprise may come for you to let go of the antenna. Involuntary, you may follow the areas low. Also, shock hazards are nearby the antennas and are energized. The rotating antenna also might cover the wall when working aloft. Most safety switches controlling the motion of the rotating antennas must be tied locked up in before and aloft near such antennas. When working near stack, you should draw aware of the recommended oxygen breathing apparatus and other toxic substances such as stack gases contain the carbon monoxide. Carbon monoxide is too unstable to build with a high concentration and opening, but prolonged exposure to even small quantities is dangerous. In Chapter 4, Summary.